Next one is classification by backpropagation. It's a neural network learning algorithm. A neural network is a set of connected input-output units in which each connection has a weight associated with it. During the learning phase, the network learns by adjusting the weights so as to able to predict the correct class label of the input tuples. Neural network learning is also referred to as connectionist learning due to the connections between units. Neural networks involve long training times and are therefore more suitable for applications where this is feasible. So it is not used for classification in all the cases. If it is feasible, we can go for the neural networks classification. They require a number of parameters that are typically best determined, such as the network topology or structure that we are using. Neural networks have been criticized for their poor interpretability, but it is having certain advantages. It is having high tolerance of noisy data as well as their ability to classify patterns on which they have not been trained. And it can be used when you may have little knowledge of the relationships between attributes and classes, and it's also well suited for continuous valued inputs and outputs, unlike most decision tree algorithms. The application areas include: they have been successful on a wide array of real-world data, including handwritten character recognition, pathology, and laboratory medicine, and training a computer to pronounce English text. Neural network algorithms are inherently parallel. Parallelization techniques can be used to speed up the computation process. So this can be used if it is feasible, and there are certain advantages of using neural networks, and we have different application areas also. The most popular neural network algorithm is backpropagation. It's a kind of multi-layer feed-forward networks, which is a type of neural network on which the backpropagation algorithm performs. We will see what you mean by that. A multi-layer feed-forward neural network. The backpropagation algorithm performs learning on a multi-layer feed-forward neural network. It iteratively learns a set of weights for prediction of the class label of tuples. A multi-layer feed-forward neural network consists of an input layer, one or more hidden layers, and an output layer. And we will see an example. This is a multi-layer feed-forward neural network with an input layer and only one hidden layer and an output layer. In input layer, we have x1, x2, xi up to xn attributes, and in hidden layer, we have certain values, and we will have an output layer here. And we will see this example again while we move forward. How we are defining a network topology. Let's see. The user must decide on the network topology by specifying the number of units in the input layer, the number of hidden layers, the number of units in each hidden layer, and the number of units in the output layer. The user must decide all these. Normalizing the input values for each attribute measured in the training tuples will help speed up the learning phase. Typically, input values are normalized so as to fall between 0.0 to 1.0. So this will help to speed up the learning phase. So normalization is good for the network or the backpropagation algorithm. There are no clear rules as to the best number of hidden layer units. Network design is a trial and error process and may affect the accuracy of the resulting trained network. A number of automated techniques have been proposed that search for a good network structure. These typically use a hill climbing approach that starts with an initial structure that is selectively modified. So we will find a network topology by a trial and error process. First we will have an initial structure and we will modify this using a hill climbing approach, and there are a number of automated techniques that can be used for getting a good network structure. And we will see what you mean by backpropagation. Backpropagation learns by iteratively processing a dataset of training tuples, comparing the network's prediction for each tuple with the actual non-target value. So it learns iteratively and it iteratively processing the dataset of training tuples, and it will compare the network's prediction for each tuple with the actual non-target value. The target value may be the known class label of the training tuple for classification problems or a continuous value for prediction. For each training tuple, the weights are modified so as to minimize the mean squared error between the network's prediction and the actual target value. So the weights are usually modified. These modifications are made in the backwards direction, that is from the output layer through each hidden layer down to the first hidden layer. Hence the name backpropagation. So the weights are modified in a backwards direction, therefore the name backpropagation. It involves two steps. First one is initialize the weights. Second one, propagate the inputs forward. Let's see, to compute the net input to the unit, each input connected to the unit is multiplied by its corresponding weight, and this is summed. This is the equation for calculating the inputs, the ij, that is given a unit j in a hidden or output layer. The net input, that is the ij value to unit j, is calculated using this equation, and it is represented here in the figure also. We have various weights. Weight 1j, that is from the input y1, and weight 2j is given and that is from input y2, etc. And we have to sum up all the weights are summed here, that is the weighted sum from various inputs, and we are adding a bias value, that is the theta value. Theta j is a bias value. We are adding it, and it is given to a function, that is an activation function is doing with the equation oj, that is equal to 1 by 1 plus e raised to minus 1j minus ij, that is the activation function. Finally we get the output. So this is the way we are calculating the weights, and the output value is represented as this. This is the example, and we will see this is the equation, and we will see the example. How efficient is backpropagation? We are seeing how this method is efficient. The computation efficiency depends on the time spent on training the network. That is the in terms of the time we are spending on the training the network determines the efficiency of this particular algorithm. We have an example here, a multi-layer feed-forward neural network. Here we have three inputs, that are x1, x2 and x3, and these are represented here as 1, 2, 3, and in the hidden layer we have 4 and 5, and in output layer we have the 6, that is the neuron here we are representing, and in each input we have a weight value, and the table 6.3 represent the initial input value, weight, and also the bias values. Here x1 is having an initial value 1, x2 is having 0, x3 we have 1, and weights also we have certain values. That these are initially we are giving some values, and later these weights will be modified in backward direction. Initial values are represented here. 0.2 is given in the weight 1/4, that is the weight from 1 to 4. That is the weight 1/4, that is given as 0.2, and weight 1/5 we have minus 0.3, and weight 2/4 we have a value 0.4. Like that we have given certain values. The net input and output calculations are based on the equations we have seen in the previous slide. We are calculating Ij value, that is we are sum up the values, weights plus the bias value. So we are calculating the net input value, that is we have the values for 4, 5 and 6 because these have input values, and we are calculating the Ij values for 4, 5 and 6, and we are also calculating the output value, that is the Oj, for all these unit J. Okay, this is an example for a multi-layer feed-forward neural network, and finally we have to see some more steps in this. Finally, rules can be extracted from training neural networks. So I'm not going into further topics, since this will be enough for your examination and point of view. So if you are interested in this particular classification method, you can read more from the text.